Welcome to Let Us Start Educational channel. This is a graph of variation of binding energy per nucleon with mass number. So on x-axis mass number is given from 0 to 210, and y-axis binding energy per nucleon is in million electron volts is given here. Binding energy for nucleon in million electron volts is given here. So let us observe this. This one is the 1H2. This is the isotope of the hydrogen, that is deuterium. So from this, binding energy for nucleon increases, and helium to neon we observe some fluctuation, some up and downs. So at iron 28 Fe56, 28 Fe56. So here we observe that binding energy for nucleon is maximum, that is 8.7 million electron volts. Iron has more binding energy for nucleon, that is 8.7 million electron volts for iron. From that it decreases gradually. So what we have observed here, its binding energy is maximum for iron. So and it decreases gradually, and it is greater for the atomic numbers 40 to 180. After that it decreases gradually. So for heavier nuclei, for stability like that, uranium, they split into other nucleons. So iron has maximum binding energy per nucleon. Binding energy of uranium is 7.6 million electron volts, and minimum is for deuterium, that is 1.11 million electron volts. So for small mass numbers, here the graph is up and downs. For helium and lithium, carbon, nitrogen, oxygen, fluorine, neon. For nucleons, helium, carbon, oxygen, neon, binding energy for nucleon is maximum. If they have even number of protons and neutrons, for small numbers only we discuss here, they have even number of protons and neutrons, they have maximum values of binding energy for nucleon. For odd number of protons and neutrons like lithium, nitrogen, fluorine, binding energy for nucleon is minimum. So here in the region of mass number 40 to 180, binding energy is greater, and they have more stable, and the nucleons have more stable. So let us observe this graph carefully to answer so many questions. So iron has binding energy for nucleon is maximum. Heavier nucleus split into smaller nucleus, and smaller nucleus combine and form stable nucleus, like two hydrogens combine and form helium for getting stability. Here we observe nuclear fusion and fission in this graph. Here heavy nuclei divides into smaller nuclei. A smaller nuclei combine and form a single nuclei. Nuclear fission and fusion, we observe this.